So without further ado, I will be passing over to Romy with a talk entitled Don't Be Alarmed. Hello, Romy.
Hi. Sorry, I was on mute.
Hi. Ready to go?
I am ready to go. Cool. So welcome to my talk. Don't be alarmed when it comes to monitoring and automated service alerts. So do be alarmed when you need to be is really what I mean from this talk. Today, I'll be giving you a brief introduction to monitoring and alarming your production infrastructure. So let's make up an e-commerce example. Let's imagine we want to build a website that sells stuff and delivers it to customers. What does this site need to do? It needs to list all of the items that we want to sell, display whether an item's in stock or not, allow a user to create an account to check purchases, save delivery addresses and pay. You want to track dispatch and delivery. There's probably a load more things that the website could or should do, but we are time limited. So I've put these in a vague priority order, and you may feel like you would prioritize things differently, but this is the basis of a basic e-commerce site. So here's our super cool e-commerce site, which I've called Skis. It's a catchy name. Architecture. So we could have built this like in a monolithic style or a microservice style, dropping some buzzwords in here for you. And just for those of you that don't know what they are, I'll do a quick diagram and explanation. So monolithic, you usually have everything kept in the same repository, all of your code, your individual services, etc. And it's all hooked up to maybe a big database with lots of different tables in it. So you can see there's lots of different tables in my database. I've got a user service, a stock service, a delivery service, all in one big repo here. And then I'm interacting with my user interface or my front end. So things can be interconnected and unexpectedly reliant on each other when they're in a monolithic application. Then we have the microservices architecture. So as you can see, does exactly what it says on the tin. There's a bunch of individual smaller services. There's multiple repositories, one for each. And the code does not rely on any other service. They're completely independent of each other, but you can make requests between the two services if you needed to. So in this case, each service has a simple database, and that's basically the microservices. So why are they the best thing since sliced bread? Disclaimer, don't force microservices when there's no business need, as it can make your life more complicated. But they're good because they're highly maintainable and testable. They're loosely coupled, so you can do stuff on each individual service, and it won't mess with anything else that you're doing elsewhere. They're independently deployable, so if you've only made changes to your user service, you don't have to redeploy your entire stack. And they can often be owned by a small team. So you might have a user team, a stock team, and another team all working completely independently, not having to worry about merge conflicts or anything when they do work. But anyway, I digress. Imagine we've built an MVP, that's minimum viable product for anyone that doesn't know, another buzzword for you. And so this is our site. We've deployed it using a cloud service provider of your choice. It's working at first, but we did a bit of dodgy code to get it live. We were in a bit of a rush. We're constantly working on new features, trying to tackle tech debt, scalability, all the good stuff. So what happens when stuff breaks? We need to know about it. We want to know about it before our customers, ideally, because this stops them complaining. Stops us losing reputation as a company, stops us losing current and future custom, because if something went wrong the last time you used a website, you're probably not going to hurry back. We also want to know as soon as things start to look dodgy. So before our services are down completely, there could be signs that something is going wrong and it's degrading progressively. So we want to know about that. We want to prevent loss of data. And we want to be able to fix stuff before disaster happens. The best way of preventing a disaster is being proactive, not reactive. If you're being reactive, that means that the disaster has already happened. So enter monitoring and alerts. We can use a third party or an independent service to query our services and infrastructure to check that they are running as expected. So if any part of our infrastructure is down or degraded in performance, we can rely on that independent monitoring to tell us. It's really important that our monitoring service isn't within our infrastructure, because if our services are down, our monitoring service would also be down and therefore wouldn't be much use to us. So back to Skis. Time equals money. Downtime equals no money in the e-commerce world. So every second counts. Think about how long you would want to wait on a website to buy an item that is also available on hundreds of other websites, but maybe for a different price. If you can't buy it because the site is down or you have to wait for the page to load, you're probably going to buy it elsewhere. So here's a monolithic example. Someone deletes the user section of the code base by accident. Like, stuff like this happens. So without any monitoring, we know that something has gone wrong because someone's deleted the user section, but this blissfully unaware developer does not. If all of our code is in the same repository and interdependent, it might take us a while, A, to be told by the customer that our service isn't working as expected, B, to find where the issue is in our complicated monolithic repo, and then more time to actually do the fixing. So our service has logs, and those will contain information that our service is down. But unless someone is looking at those logs at that particular time when the service goes down, we aren't going to know that there's an issue. So see blissfully aware, unaware developer, and sad user. So ta-da! Enter our monitoring service. So it's sitting up here in the cloud. And basically what it will do is make some HTTP requests or scan some logs if we've allowed it access to our service logs. And we can set it up to ping us when something unexpected happens. So it's constantly pinging our service going, are you working? Are you working? Are you working? And as soon as it gets a message saying, no, it pings the developer. So as devs, we are less happy because we have to fix a problem, sad times, but the customer will be happy because we know that there's a problem and we're going to quickly fix that. When it comes to microservices, someone accidentally deletes the user service, whoops. If the user service is down, or in this case does not exist, there's going to be some unexpected behavior on the front end. And similarly to before, as developers, we probably have our heads deep in some new feature code and we're blissfully unaware. So again, pop in a cloud monitoring service. It's constantly running the background, making periodic checks to see that our service is responding to basic requests. You can alter how often it actually pings the service to check that it's up and running and how often it will check the logs. Depending on what your use case is, because you might have an e-commerce site that you want to be up 100% of the time because people want to be buying 100% of the time. But if you've got like an internal service that's just being used by internal staff and isn't public facing, maybe 5 people use it, you might not want to check it so often. But yeah, we get pinged. They say, hey, this service isn't responding at all. So then the developer knows that they can either roll back to the last working release or patch a fix. So why is monitoring good? Health checks tell us instantly when our service is down. We can see when service performance is degrading and catch it before it goes down. You can create dashboards based on the monitoring data. This is really good for reporting to a business, saying like, look, we're getting loads and loads of traffic. Analysis, we're getting loads of traffic on this day, so maybe we should increase our services on that day and put some more support in line. And also it helps us see, we're getting a huge backlog in this particular service and loads of random errors. So it allows us to put more feature work and technical debt improvements into our sprints and makes them more aware of it. So the possibilities are endless. So alarming. Now we're monitoring our service, we can set thresholds to instantly notify us when things are going badly. So we need to think about what we want to be alerted. What is serious enough to disturb us? You don't want to get pinged every 5 minutes for something that isn't serious. Then when something bad does happen, you won't notice. So boy cried wolf kind of situation. So the main purpose of our site is to sell stuff. People come to the site to see what's for sale. Therefore, our highest priority is that customers see what is for sale. And then next, they want to know what's in stock so they can buy it. Without that, we have no business. So we want to measure the rate of kind of successful HTTP calls to our stock service. So those would be 200 HTTP status codes. We can do this by counting the number of non-successful codes over a period of time. We could set up an alert if the percentage of non-successful messages rises above the threshold. So here I've got how many 200 responses we've got over time, and here we've set a threshold. So if we've got a low amount of 200 responses, this is bad, we're in the alarm zone. And then once it's over that threshold, we're safe again. So we would be getting pinged every 5 minutes or however often you wanted to be pinged in this bit. Cool. We also might want to check the speed it takes our service to return information. So you don't want to be waiting 5 minutes for a page to load. So we can check what our average time to respond is. over time. And so we can see, something bad happened here. Suddenly our service was degrading, and we can be alerted before it fully outages as well, which is helping us be proactive rather than reactive. So why is alarming good? You can get instant notification of issues by email, Slack, or on a customer-facing status page. So customers can go and check on something independently and see, their service is down. You can contact different people depending on the type of the alarm. So a user team for the user accounts might get notified when the user service is down. So you don't distract other people working in other teams when it's not necessarily an issue related to them. You can also get product owners or managers or engineering managers contacted when there's a significant outage. So tools to do this. Amazon CloudWatch is a tool that I've used. So some of you may have heard of AWS. If you haven't already, they basically make loads of services that try and make our lives easier, as well as a ginormous amount of data warehouses where they are physically storing data for you. And that's what we mean by cloud. It's basically a big company storing stuff for you. So these are the kind of things that you can see on I think I've run over time. So these are the kind of things that you can see. I'll just skip through these slides. This is a kind of machine learning that these services like CloudWatch can do for you. So they'll learn what your expected rates are. And then if you go outside of that boundary, they can tell you that you're an alarm and send you notifications. And then there's some also really cool data visualization tools like Grafana. So you can make stuff look way prettier than the CloudWatch stuff. And yeah, there's, are you alarmed? Hopefully not. But I might have bored you to sleep, or you might be interested. I've got loads of links on the next page that I can send to everyone. But yeah, thanks for listening.